Welcome to Theory of Computation. Here I'm going to give an explanation for the theory part of Turing machine. That means programming techniques for Turing machine construction. So if you consider a Turing machine, it is a mathematical model which is used to define a context-free language and also used for doing some mathematical operations in it. So it is a powerful conventional computer and which can be used in programming techniques. So there are four technical notations are available for Turing machine construction. One is storage in finite control state, which means that we want to store the current state of a particular symbol in a tape. So if you consider a tape contains only symbols in it. And we maintain each cell with the current state in a control head. Using that state only, the symbol can be replaced or we can stay at the same state. So storage means it's not only to store the alphabet symbols in an input tape, but also to store the current state at a particular cell. So this concept is also available in a storage in finite control. Using that only we draw the transition diagram for each problem. So in each problem, the state is maintained, and from that state only the outflow is available with the cell symbol and also the replacement symbol. So in this way we can able to maintain the finite state control storage states. And the second programming technique is we can able to solve for finding the number is even or odd, or a number is prime or not. For implementing the solution for these two problems, we should go for multiple tracks. So what is the concept of multiple track means? It contains a single cell which is divided into three track. So the tracks are 1, 2, 3 like that. So it will be mentioned in a Roman letter. So here I am going to take an example as m is equal to 3 and I want to find whether 3 is even or odd. So we already know the procedure for finding the number is even or not odd. Any number which is divided by 2 and it should give 0 means that number is even. Any number that is divided by 2 and it will give the remainder as 1 means it is treated as odd. But we are not dividing division operation. Instead of that, we are using subtraction operation here. So initial value is stored at layer 3 and layer 1. So the same value is stored, and track 2 is in which number we want to divide it. So we are finding even or odd by using the number 2. So that number 2 is stored in layer 2. Then repeated subtraction means we only subtract the value at layer 1 and layer 2, and the remainder will be stored in the resultant value is stored at layer 1. So if you consider this one, 3, 2, 1 will be stored. So we should repeat this process until the layer 2 value should be greater than layer 1. If layer 2 is greater than layer 1, we should stop the procedure and we want to check the layer 1 value. So if layer 1 contains 0 means the number is even, otherwise the number is odd. For example, I am taking the number 9, whether 9 is even or odd. So the same number is stored at layer 1 and 3, and we should subtract layer 1 and 2, the resultant value should be stored at layer 1. And again we repeat the process because layer 2 value is less than, layer 2 value is less than 1 means repeat subtraction. So 7 minus 2 is 5, then 5 minus 2 is 3. Here also layer 1 value is greater than layer 2. So we repeat the process, 3 minus 2, 1. So 9 to 1, here layer 2 value is greater than layer 1. So we stop the procedure and check the layer 1 value. If it is 1, the number is odd. For example, I am taking 4. So I want to check whether 4 is even or odd. So here layer 1 value is greater than layer 2. So subtraction means 4 to 2. Again greater. So 4 to 2 minus 2 is 0. So layer 2 value is greater than layer 1. So stop the procedure and check the value. So layer 1 contains 0 means the number is even. So in this way we can able to find out the number is even or odd. And the second problem is for finding the number is prime or not by using the same multi-layer technique. So if a number is prime means that should be only divided by itself and 1. So if I am taking n as prime number, that number is only divided by n and 1. But we should check the number from 2, 3 like that onwards. So we repeat the process until for checking 2 to n minus 1. So initially I am taking the n value as 5. So we should start from 2 onwards. The same repeated subtraction procedure. So 5 minus 2, 3, 3 minus 2, 1. So in this situation, layer 2 value is greater than layer 3. We should not stop it. Instead of that, we only increment the layer 2 value because the given number is not divided by 2. So we want to check whether the number is divided by 3 or not. So we increment the second layer value by 1. So here previous value is 2, now its value is 3. Repeat the same subtraction, 5 minus 3 is 2. Layer 2 value is greater than layer 3. So we stop the procedure and increase the value by 1 at layer 2. So now 5, 4, 5 repeated subtraction means 5, 4, 1 occur. Layer 2 value is greater than layer 3. We stop the procedure and increment the layer 2 value. Now layer 1, 2, 3 contains same value. So if the number is prime, all the layers should have the equal values. Otherwise, the layer 3 contains 0. So if it is 0, the number is not prime. If it is prime, all the layers should contain the same value. So in this way, we can able to implement the finding of even or odd by using the multiple track notation. And the third problem is the usage of subroutine. So it is also discussed in multiplication operation. So multiplication operation means f of m comma n is equal to m into n, which is nothing but repeated copying of n number of values by m times. So it is already discussed in previous lecture video, just go through it. And the fourth condition is checking of symbols. So checking of symbols means we want to check the symbol at each layer. Either 0 or 1 will be stored like that, and we can move to either forward direction or reverse direction. So it is the way we can able to solve it. For finding odd length, so we can able to find odd length, or we can able to find odd number of zeros. So for that situation, we only move to right direction. So it's not necessary to move to left direction. So in this 4 method, the programming techniques can be implemented for the construction of Turing machine. Thank you.